Hello everyone, today we are going to see about A-star algorithm. It is one of the Dijistra's graph algorithm where we have not been known recently in many places. It is most important algorithm in graph. Now let's see. So this A-star algorithm, it is an informed search algorithm, or it is also called as heuristic search algorithm. Why it is means it gives the shortest path by measuring the cost of that particular graph nodes. So here this A-star algorithm, it determines the lowest cost path between any two nodes, and here the directed weight graph is being analyzed and the cost is being analyzed where without any negative edges. Okay, and in this graph algorithm we are determining the node to explore the cost of it. In this A-star algorithm we are mostly using it in games and also for the GPS maps to find the shortest path as early as possible. So this plays major role in all your two-dimensional games and other tree of paths for originating at the start node, and it extends its path from one edge at a time. So it continues until the termination is satisfied. So in this, it minimizes the function by using the formulae f of n is equal to g of n plus h of n. So this f of n is the estimated value of the node by finding the g of n and h of n. Your h of n is nothing but the heuristic function value, and g of n is the cost of that particular node. So the implementation of the A-star algorithm involves maintaining two lists, open and closed. This open contains the nodes that we are going to evaluate and evaluate the heuristic function, and then we'll expand it and we'll have it in the successor, where we will not have the successor, but in the closed it contains the nodes that we have already visited. So first process is we have to define the list open. Then for defining the list, initially we have to open and that open should consist of single node, that is start node. So if the second step is, if the list is empty, we have to return failure and exit the node. Next, third step is we have to remove the node from the smallest value of the estimated function value, where the open from the open and move it to its closed function. If the node is in goal state, we have to return success and we have to exit the node. And if at all we doesn't have that, then we have to expand the node by using the n nodes. If any successor to n is goal, if we are going to reach the goal node, then we have to return success, and then the solution will be traced by finding the path from goal node to S. S is nothing but your starting node, and if the node is a goal state, then it returns success and exits. If the traced path is not the success value, means we have to again move to step 6 and continue the process until we get the goal node. For each successor node, we have to apply the evaluation function to find the node value, and if the node has not been in either of the list, means it has been added to the open. Then after that function, your last step is go back to step 2. That is, you have to repeat this process until you get the goal node. So let us see a problem from your question bank of your gate. This is one of the problem where in this graph the numbers written on the edges represents the distance between the nodes, and the numbers written on the nodes represents the heuristic value. So all these red color values are your heuristic values, where the number represented in the distance between the nodes is your distance values. So what they have asked is find the most cost effective path to reach from start state A to end state, that is final state J, using A star algorithm. So in this, the first step is we have to start with node A, and we have to traverse throughout this graph and find the lowest cost weight value of this graph. So this node B and node F can be reached from node A, because we have the directions from A to B and also from A to F. So this A can reach the goal by using either node B or node F. So what we have to do, we have to find the weightage of f of b and f of f. So your f of b is equal to your g of n plus h of n, where your g of n is 6 and your h of n is 8. So your f of b value is 14. And for f of f, the distance between a and f value g of n is 3, and your weighted value, your cost effective value of the h of n, your heuristic value is 6, so your total value will be 9. Since your f of f value is less than f of b, it takes the path from a to f and it moves on. Next, so your A to F path is defined now. Then after that we will be checking with from F to G and H. So f of G and your f of H is calculated, where your f of G is 3 plus 1, that is 3 plus 1 plus 5, that is 9, and your f of H is 7 plus 3 plus 3, that is 13. F of H, so it decides and it moves from path A to F and F to G. So it takes this path. Node I can be reached from node G. Here node I can be reached from node G. So it takes the function weighted value from f of 1, that is 3 plus 1 plus 3 plus 1, that is equal to 8. Here your value is 3 plus 1 plus 3 plus 1. Your heuristic value is 1, so 8 is calculated. So it decides and moves from A to F and F to G and from G to I. Then step 4, after reaching I, it takes two paths in f of E and f of J. It checks both the things, where f of E is actually 3, so that is equal to 15, and 5 plus 3 is 15. Then f of H is 3 plus 1 plus 3 plus 2, so that is 12. And your f of J is 3 plus 1 plus 3 plus 3 plus 0, because your J doesn't have the weighted heuristic value, so your f of J is 10. Since f of J has the least value, it decides to go to node J, and at last we are having the shortest path from A to F, F to G, A to F, F to G, G to I, and I to J. So this is the required shortest path from node A to node J, where your cost is also very less. So your A-star algorithm is one of the best path finding algorithm, where it does not produce shortest path always. Sometimes it does produce the cost effective path, So it does not always produce the shortest path. Next is, it heavily depends on your heuristic value. So it is entirely depends on your heuristic value, and the space and time complexity of your A star algorithm is O of V plus E. We'll see another problem that is based on your tree. So this is entirely different. So based on your tree, it takes the cost value and it gives the final node reaching value. The problem and final state to be reached is given here. So this is a 3x3 matrix puzzle where we have to reach this final state from initial state. So what we have to do, we have to find the most effective path to reach the final state from initial state. So in this, your G of n is the depth of the node and H of n is number of misplaced tiles. So here it entirely differs. It does not get the cost value. Here it takes the number of misplaced tiles. So your A star algorithm, here it maintains a tree of paths from initial state to your final state. So here your initial state, your G will be always 0 and your H is nothing but your misplaced tiles. So your misplaced tiles in initial is 4. So your F value will be 0 plus 4, that is 4. Next is, we are moving to the next level of your tree, so that your G becomes 1 and your H value becomes 5 here, because here we have misplaced tiles. Misplaced tiles here are 5 and here your misplaced tiles are 3 and here you have misplaced tiles of 5. So your F value will be 1 plus 5, that is 6, and here it is 1 plus 3, that is 4, and here it is 1 plus 5, that is 6. And from here we will take the minimum value, that is the least value, and will process. So from this we are again moving to the next tree where your G of value will be 2 and your here also you will have 3 different formats here, where your H value here, that is your misplaced tiles here are 3 and here also your misplaced tiles are 3 and here it is your misplaced tiles are 4. So what happens, your effective value becomes 2 plus 3, that is 5, and here it is again 2 plus 3, 5, but here it is 2 plus 4, 6. So here we have two tree values having same effective value. So what happens, we will have another 2 subdivisions from that is your G value will be 3 and your misplaced tiles here are 3, but here your misplaced tiles are 4. So what happens, your effective value becomes 3 plus 3, 6. So when we check this, so again it takes the least value and it again moves to the next tree traversal where your G value will be 4 and your misplaced tile is only 1 here comparatively to your final state. So your cost effective value will be 4 plus 1, that is 5. So after this, the last step is next tree traversal where your G value will be 5 and your H is 0, because your misplaced tiles now it is 0. Why? Because you have reached the final state here. So your effective value is 5 plus 0, that is 5, and here it is 2 misplaced values, so you have 5 plus 2, that is 7. So comparatively this is less cost effective, so this will be your final state. So this is your entire traversal process where we have traversed from initial state to final state. So this is your first level of traversal, and this is second, and this is third, this is your fourth level, and this is your last fifth level of your traversal. Thank you all. We'll meet you in next session.